So we've got a mini disc player provided with a mains adapter, and the adapter uses a transformer with a turns ratio of 15:1 to step down the mains voltage from 230 volts. You've got to calculate the output voltage from the transformer. The second thing you've got to do is then state 2 reasons why the transformer may be less than 100% efficient. Alright, so jumping across. What we have then initially is, from your formula sheet, you know that the number of turns across the secondary divided by the number of turns across the primary is the voltage across the secondary divided by the voltage across the primary. We're interested in the output voltage, so the output is the secondary. So your voltage across the secondary then is the number of turns of the secondary divided by the number of turns of the primary times by the voltage across the primary. Now, we know that this is a step-down transformer, and the turns are in a ratio of 15:1. So that means there will be less turns on the secondary than on the primary, so that it's a step down. So I've got 15 turns on the primary, 1 turn on the secondary, and I've got my initial voltage of 230 volts applied. So if I plug those numbers into my calculator, 230 divided by 15 gives me an answer of 15.3 recurring volts. Now if I look at this, these are integers, no number of infinite decimal places. These I'm going to take to mean 230 volts. So I'm going to take that to mean that's 3 significant figures. So my answer is going to be 15.3 volts, and I'm giving it to 3 significant figures. Okay, part 2 then is asking us, they are 2 reasons, but I'll do a few more. State 2 reasons why the transformer may be less than 100% efficient. So the first thing you've got on a transformer is the windings. So the windings in the coil that make up the coils, the windings in the coils have a resistance. So they've got a resistance, therefore heat up when a current passes through them or flows through them because of the heating effect. So it's actually the electrons bumping into losing kinetic energy as they bump into the positively charged lattice ions as current passes through them because of the heating effect. Now that you can calculate the power lost by using the equation I squared R. If you're doing your GCSE, you probably remember it as twinkle twinkle little star, power equals I squared R. So we've got the windings that can heat up. That then reduces the efficiency. I'll put here reducing. Reduces efficiency because what happens is your transformer gets warmer rather than giving you electrical energy out the other side. So the next thing that I was talking about is your eddy currents. So your eddy currents in the coil, not in the coil, in the core. So the eddy currents in the core, they're reduced in the core, so you get eddy currents in the core, cause energy loss in the core, and therefore it reduces the efficiency of the transformer. Another possible answer is that energy, I should have said on the previous one, so you reduce this by reducing the resistance to the windings. You reduce this effect by having laminations within the core, so layers of metal and insulator, metal, insulator, metal, insulator. Then in the you actually have to magnetize and demagnetize the core. So energy is used to magnetize and demagnetize the core. Therefore, reducing efficiency, because some of the energy you're putting in isn't coming out as electrical energy, it's being used to magnetize and demagnetize the core. Now, magnetize and demagnetize the core, the way you get around that or reduce that is to use a soft iron core, because it's easier to magnetize and demagnetize, therefore takes less energy, so it's more efficient. The final one then is about where the flux goes. So 100% of the magnetic field produced by the primary coil does not pass through the secondary coil. Therefore, reducing your flux linkage from the optimal 100%, which will reduce your induced voltage, etc., 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 and overall reduces the efficiency. Now, they've only asked for 2. This question is normally for about 2 marks, asking you for kind of 2 of the 4 things you could possibly answer. Hope that's useful. Thank you very much.